Here we're going to look at how we can work out the pH of a strong base. Now, in order to work out the pH of a strong base, we must know the Kw. And remember that Kw, the ionic product of water, is equal to the concentration of the hydrogen ions times the concentration of my hydroxide ions. So if I want to know the pH of a strong base, I need to rearrange this equation to get the concentration of hydrogen ions. And the hydrogen ion concentration then is equal to the Kw divided by my hydroxide ion concentration. And obviously once I've got my hydrogen ion concentration, I can do minus log to the base 10, and that will give me my pH. Now, you may be asked in certain instances to work out the concentration of hydroxide ions given the pH, and we would simply then rearrange this equation to get your hydroxide ion concentration, which would be OH minus equals your Kw value over H plus. And remember, if I'm given the pH, I can work out this H plus value here from the following equation, 10 to the minus pH. So if I'm given the pH and I'm given the Kw, I can work out my hydroxide ion concentration. Let's have a look at a few examples. And again, we need to know the Kw in order to work out the hydroxide ion concentration from pH, or the pH of a strong base given the concentration of hydroxide, or the concentration of the strong base. And I'm assuming for all these calculations that the Kw is 1 times 10 to the minus 14 moles squared decimeters to the minus 6. And the first question we're asked is to work out the pH of a 0.150 mole per decimeter solution of sodium hydroxide. And we have to make the assumption then that sodium hydroxide in solution, it fully dissociates into sodium ions and hydroxide ions. And the assumption I'm making is if I've got 1 mole per decimeter of NaOH, I will form 1 mole per decimeter of hydroxide ions. So this value here of 0.150 moles per decimeter solution of sodium hydroxide, I can assume that I've got a concentration of 0.150 moles per decimeter of hydroxide ions. So let's have a look at this particular calculation. I would use this equation here to work out my hydrogen ion concentration first. So my hydrogen ion concentration then is equal to Kw 1.00 times 10 to the minus 14 divided by my hydroxide ion concentration of 0.150. And that gives me a hydrogen ion concentration of 6.67 times 10 to the minus 14 moles per decimeter. And in order to get the pH, we'll remember that pH is equal minus log to the base 10 of hydrogen ion concentration. And that gives me then a pH of equal to 13.18. Let's have a look at another question. This time I've been asked to calculate the pH of a 0.01 mole per decimeter solution of barium hydroxide. Now with barium hydroxide in solution, this dissociates into Ba2 plus ions and 2 hydroxide ions. So if I've got a 1 mole per decimeter solution of barium hydroxide, I'll actually have 2 moles per decimetre of hydroxide ions. So if I've got then a 0.01 mole per decimetre solution of barium hydroxide, I'll actually have 2 times this number for my moles per decimetre, my concentration of hydroxide ions. So if we have a look at this calculation, then my hydrogen ion concentration, remember first, we need to work out that's equal to 1.00 times 10 to the minus 14 divided by my hydroxide ion concentration, which is going to be this number times 2. So it's going to be 0.0200. And that gives me a hydrogen ion concentration of 5.00 times 10 to the minus 13. And if I remember that pH is equal to minus log to the base 10 of hydrogen ion concentration, that then gives me a pH of 12.30. So we've worked out the pH of a strong base given the concentration of the strong base. Okay, and we've done this for what we call a monoprotic base, sodium hydroxide, and a diprotic base, barium hydroxide. Now we're going to look at seeing if we can work out the concentration of a strong base given the pH. My hydroxide ion concentration then is what I'm going to work out, and that's equal to Kw over H plus, which is really the same as saying my hydroxide ion concentration is equal to Kw divided by 10 to the minus pH. So in this particular example then, I've got to work out the concentration of sodium hydroxide with a pH of 13.40. So I first work out my hydroxide ion concentration, that's equal to 1.00 times 10 to the minus 14 divided by 10 to the minus 13.20. And that gives me an answer of 0.251 moles per decimetre. Now remember, that's my hydroxide ion concentration. But because I've got a strong monoprotic base, this hydroxide ion concentration is also equal to the concentration of sodium hydroxide. So my answer would be 0.251. And now I've been asked to calculate the concentration of a solution of barium hydroxide with a pH of 12.75. So again, I follow the same procedure as above. I'm going to do this equation here. So my hydroxide ion concentration is equal to 1.00 times 10 to the minus 14, that's my Kw, divided by the pH, which is 12.75, so it's 10 to the minus 12.75, and that should give me an answer of 0.0562 moles per decimetre. But remember, this is my hydroxide ion concentration, and if we go back here, that my barium hydroxide concentration is going to be half my hydroxide ion concentration. So if I want my barium hydroxide concentration, I would divide this answer by 2, and it gives me an answer of 0.0281 moles per decimetre. And that there would be my answer. So in this particular video, we've looked at how we can work out the pH of a strong base, given the concentration of a strong base, and how to calculate the concentration of a strong base, given its pH.